Good afternoon. This is chapter 2a for Algebra 1, which is actually the pre-chapter to starting algebraic solving. Our topic today on day 14 is dividing with variables and complex or stacked fractions. At the same time, we're going to cover how to divide whole numbers, how to reduce fractions, how to evaluate with division, how to convert mixed to improper. These are all skills that we've covered before in much greater depth. So if you are still stuck, then look back in your notes and watch the videos that show additional examples of these. So the first topic is to find a quotient, and the word quotient means the result of division. It's just easier to say quotient. All right, so for example, we're just going to do simple division of whole integers. 24 divided by -3. All right, when you have the division symbol, this looks like a little fraction. The first number goes on the top of the fraction, the second number goes on the bottom of the fraction. So this gives us a positive 24 on top with a -3 on the bottom. So to simplify this, if you know that 8 times 3 is 24, it goes a lot faster. But if you're not sure, we've been practicing simplifying fractions with prime factorization. Prime factorization is where you break a number into its primes and divide out what you can, thus reducing it. But first, let's do the signs. A positive divided by a negative is a negative. You need to have the negative on the top of the fraction, never on the bottom. To prime factor 24, think of any two numbers that give you 24. 2 times 12, 8 times 3, 6 times 4. I'm going to use 6 times 4. Breaking 6 down, it is 2 times 3. Breaking 4 down, it is 2 times 2. On the bottom, we have a 3, which is a prime number, so we're done. 3 divides into 3 one time, and we're left with a negative times 2 times 2 times 2, which is -8. So with whole numbers, you can just stack them and reduce, and the result will be either a fraction or a whole number. All right, Roman numeral 2. We are going to evaluate with division. And we've done evaluating before. The word evaluate means you're going to substitute in numbers for the variables, for x and y and z, and then simplify. Whenever you see evaluate, the result should be a number because you've replaced the x's and the y's with numbers, so there should only be number values left. All right, we'll start with one that's pretty simple. X minus 2 over y, semicolon, if x equals 5, y equals 2. Remember, the semicolon doesn't mean anything mathematical. It's simply a spacer to separate the expression from what you're replacing. So x is a 5 minus a 2 over, and y is a 2. I don't need parentheses because there's nothing being multiplied by x or y. I can just substitute in the numbers. Now, a fraction bar is a grouping symbol. So you're first going to reduce the top. Then second, you're going to reduce the bottom because you always do grouping symbols from the inside out. So the top, the bottom, and then the third step is going to be actually to reduce the fraction top and bottom. So this one's really simple because 5 minus 2 is 3 halves, which doesn't reduce. Okay, let's do another one that's a little bit more complicated. 3x squared minus 2 all over xy. And I'm going to use a different notation if x equals 2 and y equals -1. This is one where x and y are being multiplied or squared, so you're going to have to decide where you need parentheses. Now, if I put the x and the y values into the equation without using any grouping symbols, you can see right away what the problem is. So here's my 3, and then x is 2, squared minus 2 over x and y, so 2 and a negative 1. So the reason you know you need parentheses is the original x was being squared. The 3 wasn't. The 3 is a scalar being multiplied by the x squared. We just don't write the dot. So when you substitute the 2 in, you need to use a dot or parentheses so that just the x is being squared, not the 3. So it's not 32, it's 2 squared times 3. On the bottom, you have an x next to a y, which means there's an invisible times symbol. Obviously, when I substituted in the 2 and the negative 1, we're no longer being multiplied. It says 2 minus 1. So the fix, again, is to put parentheses where appropriate. We want x times y, so 2 times a negative 1. All right, so the evaluation process is the same. First, we're going to do the top. Second, we're going to do the bottom. Last, we will do top and bottom. All right, so on the top, we're going to use order of operations. We're already in the grouping symbol. So after grouping symbols come exponents. So we're going to do the 2 squared. 2 squared is 4. So now I have 3 times 4 minus 2. Now you can bounce between the top and the bottom, but that tends to cause more mistakes. I usually do the top until it's done and then do the bottom until it's done. So still on the top, after exponents comes multiply. We're going to do 3 times 4, which is, skip 2 lines, 12. And then the last thing you always do is add, subtract. 12 minus 2, skip 2 lines, is a 10. We're done with the top. That's first. Now we're going to do the bottom. 2 times a negative 1 is a negative 2. And there isn't anything else to do, so I'm just going to copy it down. So now I have 10 over negative 2. The third step when simplifying a fraction or a division expression is to do top and bottom. So the top is a positive, so a positive divided by a negative is the same thing as a positive times a negative. It is a negative, but it goes to the top where we want it. You know that 2 times 5 is 10, but if you're not sure, break it down. 10 is 2 times 5 over a 2. Divide out the 2's, and you get a negative 5. That is your simplified form. So just as a reminder on the side here, there are no negative monomials, which means one term, on the bottom. You always simplify it up to the top. Okay, so that is our evaluating and reducing fractions. I'm going to flip the page and we're going to get into stacked fractions. All right, so Roman numeral 3. Stacked, or another word is complex fractions. And stacked fractions is one of those skills that we learn it in its most basic form now, and then we keep adding on to it. Here's some examples from the SAT test, the one that you need to go to college. Here's the progression of difficulty from where we are to where we're going in later math classes. We're going to learn how to do very simple stacked fractions. Later on this year, we will involve the addition of stacked fractions, and in the spring, we will start doing stacked fractions that need a common denominator. This problem here we'll do a little bit on, but mostly that's Algebra 2, and this is we're getting into pre-calculus. So the purpose of learning to divide fractions with a stacked method is to get from here to here. Many of you I know learned how to do fractions with expression that is what, flip the guy and multiply, which does work, but it won't get us from here to here. There's nothing to flip and multiply in either one of these. So we're going to use a method for the simple ones that will work all the way through. That's the goal. All right, here are the steps for stacked fractions. Number 1, you're going to convert all mixed fractions to improper form. And you can do this any way you want. I would say if you can't remember the shortcut, you probably shouldn't use it because at this point you need something you can remember. So here's the non-memorized method. You take a mixed number like 2 and 1/3, and 2 and 1/3 is really 2 plus 1/3. It's like 2 and 1/3 cups of flour. You do 2 cups, you change measuring, and then you do the 1/3. So to make this into improper, all you do is add 2 plus 1/3, which actually makes logical sense. So when you add fractions, you need a common denominator. The 2 needs a 3 on the bottom. So we multiply by 3/3. That gives us 6/3 plus 1/3, which is 7/3. That is improper form. This is mixed form. That is the no shortcut method. The shortcut method, if you can remember it, is you take the bottom number times the front number plus 1. So 3 times 2 is 6, plus 1 is 7, and then it goes over the original denominator. Obviously, the shortcut is shorter, but you have to remember it correctly to make it work. So be judicious in which method you choose to use. All right, step 2. You're going to stack the fractions. Some of them will come already stacked, but since we're practicing stacked fractions, if they're not already stacked, you go ahead and do it. Put any whole numbers over a 1. Now that you have it set up, step 3, this is the big step. You're going to multiply the bottom by its reciprocal. And the word reciprocal indicates you flip the original, and the result when it's been flipped is the reciprocal. So multiply the bottom by its reciprocal and the top by the same number. So the bottom fraction provides you with the reciprocal that you use on both the top and the bottom. All right, step 4. Divide out the bottom. Divide out the bottom to 1. Reciprocals always multiply to get a 1. So basically, you're going to eliminate the bottom of the fraction by multiplying the original by its reciprocal. Now, since anything over 1 is itself, all you have is the top. So you're just going to simplify the top. All right, these steps are here for your information. If writing them once helps you remember them and you're good, you don't need to refer to them. But if you get stuck, flip back to your notes and walk through the steps one by one to get through the process. All right, put a line down the middle. We're going to do 2 examples. So here's the first one. -1 and 2/5 divided by 2x over 3. So the first thing you need to do is to convert the mixed number to improper. Whether you use the shortcut or not, it ends up being -7/5 divided by 2x over 3, which is already improper. Step 2, stack the fractions. So -7/5 over 2x over 3. First one goes on the top, second one goes on the bottom. Step 3, multiply the bottom by its reciprocal. So the reciprocal of 2x over 3 is 3 over 2x. And then you're going to multiply the top by the same number, 3 over 2x. What happens is when you multiply an original number by its reciprocal, everything divides to 1. 3 goes into 3 one time, 2x goes into 2x one time, and the entire bottom of the fraction equals 1. As you know, any number over a 1 is itself. So we can now disregard the bottom and just work with the top. On the top, we have negative 7/5 times 3 over 2x. And this is just straightforward simplifying, multiplying fractions. Multiply straight across. You get negative 21 over 10x. And you can tell looking back a step, there's no prime numbers that are going to divide out. So that would be your answer. So again, switch mixed numbers to improper, stack them up, multiply the bottom by its reciprocal, multiply the top by the same reciprocal, the bottom cancels out, and you just do the top. That's the whole process. All right, let's do one more example. Example 2 is 2x divided by negative 1 1/3. All right, so your first step is to put the whole numbers over 1. So 2x over 1. And change the mixed to improper, which would be negative 4/3. Step 2, this is an x, stack your fractions. So 2x over 1 goes on the top, and negative 4/3 goes on the bottom. Step 3, multiply the bottom by its reciprocal. The reciprocal of negative 4/3, you flip it, is 3 over negative 4. And that tells you to multiply the top by the same thing, 3 over negative 4. On the bottom, when you multiply a number by its reciprocal, everything divides to 1. 3 goes into 3 one time, negative 4 goes into negative 4 one time, and now the entire bottom is just a 1. So you're left with the top. And the top is 2x over 1 times 3 over negative 4. Notice how the 1 helps the numerator and the denominator to line up. Now, just looking at this, I can tell that 2 is an even number and 4 is an even number, so there will be things to reduce. So to save time, rather than multiply it into 6/4 and then refactor it, we're just going to factor it in this form. So push the numbers to the front, 2 times 3, x last. On the bottom, your negative becomes a negative 1. 4 is 2 times 2. We can divide a 2 out of the top and the bottom. We also know that a positive divided by a negative is a negative, so the top term will have a negative on it, and multiply what's left. 3 times x is 3x, and all I have left on the bottom is a 2. And that is your answer. Again, remember where we're going with stacked fractions. We are trying to get from where we are, which is this easy one, all the way over to these. So the technique we're practicing, which is required on the stacked fractions worksheet, is so that you learn the process when the numbers are simple, and then later when things get more complicated, you will be able to accomplish the same thing with definitely more complicated terms to factor and reduce. Have a good afternoon.